Hello, everyone. My name is Lydia Kim. I'm an economist at the World Bank working in the Poverty and Equity GP, global practice. And I was lucky enough to be able to work with the NSO survey team in the estimation of the 2020 national poverty rates. Today, I'll be giving a short presentation on the methodology that we used. And what I'll be presenting is based off of a technical note that we've written with the NSO survey team. So for those interested in more of the details, I think you can refer to this note. Okay, so I'll go into some background about why the methodology used for estimating poverty was different for 2020. And then I'll give some details on the methodology that we used, which is called SWIFT Plus, and how we applied it to the 2020 Mongolia Household Socioeconomic Survey. And finally, I'll end with some brief results of the 2020 estimation. Okay, so first some background on poverty estimation in Mongolia. Recent official poverty estimates are based on the HSES, which has been implemented every 2 years since 2012. It's representative of the nation, urban rural areas, locations, and since 2016, AMAGs as well. And as you probably already know, the normal method of measuring poverty involves creating a consumption aggregate and seeing what share of the population has a level of consumption below the poverty line. However, the method used for 2020 was a bit different. And the reason for this lies in a number of changes to the 2020 survey questionnaire, specifically the consumption modules. First, the reference period for the food diary, which is used to measure food consumption for only urban households, was reduced from 1 month to 1 week. Second, the number of non-food items was also consolidated. And I should mention that these changes were made in order to reflect international best practices in collecting consumption data. And studies have shown that these types of changes to the questionnaire could have tangible effects on the consumption aggregate. And the problem is that it's very difficult to estimate how big these effects might be. So this means that the consumption aggregates constructed from the 2018 and 2020 HSES consumption data are not comparable. And this in turn poses a problem for estimating how poverty changed between 2018 and 2020. And I should also mention that since the 2022 HSES and those following are going to have the same questionnaire as 2020, the consumption aggregate from 2020 will be comparable with the 2020 consumption aggregate. So the use of SWIFT Plus is really just a one-off solution for 2020 in order to see how poverty changes between 2018 and 2020. So the question that remains then is, how do we create measures of consumption and poverty in 2020 that are comparable to previous years? The method that we have used to estimate poverty in 2020 is a well-known World Bank developed method called Survey of Well-Being via Instant and Frequent Tracking, or SWIFT for short. And we used a version of SWIFT called SWIFT Plus, which adapts the original methodology for times of economic shocks or downturn like the COVID-19 pandemic. SWIFT is a survey-to-survey imputation approach that has been used very extensively. As you can see here, SWIFT Plus has been used in a number of countries recently to estimate national poverty rates. So what is SWIFT Plus? Survey-to-survey imputation approaches like SWIFT Plus require 2 surveys. One survey will be the survey in which you are planning to impute consumption. So for us, this survey, which we call the imputation survey, is the 2020 HSES. The other survey, which we call the base survey, will be a recent survey that has a reliable consumption aggregate. And for us, this is the 2018 HSES. So the basic premise of SWIFT Plus is to use the base survey or the 2018 HSES and model consumption using a number of correlates of household welfare. So this model will then be applied to the 2020 data, which will give us a predicted or imputed value of consumption for each household in 2020. And this imputed value of consumption will then be used to estimate poverty using the existing poverty line. So there are quite a number of steps involved. I'll go through them one by one. In the interest of time, I won't go through all the details, but if you're interested in learning more, you can refer to the technical note. Okay. So once you have your two surveys, the first step is to identify a pool of time invariant variables that are comparable in both surveys. These variables will be used to model or predict consumption in 2018. So they should be correlated with welfare. So what are time invariant variables? They are variables that do not change much with time. Some examples include car ownership, the educational attainment of the household head, the household size. And these variables are subject to change, but it's unlikely that they're going to be changing very quickly, even in response to an economic shock like the pandemic. So you can think of time invariant variables as slowly changing variables. One important factor of step one is that the time invariant variables that you've chosen for the pool are comparable across surveys. And we can normally check whether they're comparable by looking at their means across the two surveys. The second step is very similar to the first, except that instead of time invariant variables, we identify a pool of comparable time variant variables. As you may have guessed, the time variant to variables are variables that change pretty quickly. Some examples are consumption variables, like whether or not a household consumed meat in the past week or bought clothes in the past year. And these variables are typically more sensitive to current economic conditions and can thus better pick up impacts of shocks like the pandemic. So as an example, it's unlikely that time invariant variables such as the educational level of the head or what type of house you live in will change in the short term as a result of the pandemic. However, it is likely that a household may stop consuming certain items like meat or clothing in the face of a negative shock. So these time variant variables pick up short-term changes in household welfare, which for us is important since we want to know, we want to see how household consumption was impacted during the pandemic. And so we call this model that includes both time variant and time invariant variables a post-COVID model since it measures poverty during the pandemic. So now we've identified a pool of time invariant and time variant variables from which our post-COVID model will be based. But we can't include all these variables into the model because it's likely that issues of overfitting and multicollinearity will arise. So in step 3, we want to instead select the set of variables that predict consumption most accurately in 2018. And how do we do this? So we use something called a stepwise regression. First, we start with a full unrestricted specification, which regresses log per capita household consumption on the entire pool of time variant and invariant variables. Then we sequentially remove the variable with the lowest predictive power or the highest p-value from the model. We keep on doing this until we end up with a set of X variables that most accurately predicts consumption. There are a number of criteria that determine what constitutes most accurate, which I won't go into detail here, but you can find them in the technical note. So step 3 gives us an optimal set of predictors that we use to estimate the model. Based on this model, we get a predicted value of consumption for each household in 2018 that we can compare to the actual value in 2018. And this will give us a sense of how well the model is performing in 2018. Then in step 4, we use the model we estimated in step 3 to impute consumption in 2020. We can apply the model to 2020 data in order to get an imputed value of consumption for each household. An important assumption to note here is that coefficients, which represent the relationships between the predictors in the model and household consumption, do not change significantly between 2018 and 2020. And this is why it's important for the base survey to be as close in time to the imputation survey as possible. Because it's likely that as more time passes, the relationships between the predictors and consumption will change. So to impute consumption in 2020, we also employ something called multiple imputation, which is a widely used method to deal with missing data problems. And one of its benefits is that it is able to produce more unbiased estimates of consumption and its distribution. So just briefly, multiple imputation adds a random error term to the consumption value and does this 20 times, resulting in 20 values of consumption and poverty for each household. Using these 20 vectors, we are able to then estimate the overall poverty rate. So as you can tell, multiple imputation has some implications for actually working with the data. But fortunately, Stata has some very nice commands that simplifies things. So for those who are interested in working with 2020 welfare data, we've created a do file with some sample syntax that can be shared by the NSO. Okay, so the final step involves validating the model estimated using 2018 data by checking how it performs on other surveys, normally previous surveys such as the 2016 HSES. And this gives us evidence on whether or not the 2018 model does a good job in predicting poverty in other years. Which then gives us an idea of whether it will do a good job of predicting poverty in 2020. We do the validation by imputing consumption and poverty using multiple imputation in 2016, as we did for 2020. But now we're able to compare the imputed poverty rates to the actual ones since the 2016 HSES had a consumption aggregate that was comparable to 2018. If we see that the imputed and actual 2016 poverty rates are not statistically different, then we can be reassured that the 2020 poverty rates will be pretty accurate as well. Okay, so these are all the basic steps of Swift Plus. Now I'll go into a little more detail of how we actually carried out the estimation of poverty in 2020 using this method. So as I mentioned previously, the AMAG is the lowest geographical level for which the HSES is representative, and therefore it's the lowest level for which we can estimate poverty rates. If we want to estimate AMAG level poverty rates using the 2020 HSES, we would normally need to construct a separate model for each AMAG. So this would mean 22 distinct models, which is not feasible using the 2020 HSCS because sample sizes are quite small. And even within certain AMAGs, urban and rural areas differ quite a bit. So urban and rural areas tend to have very different livelihoods and lifestyles. So creating one model that covers both is actually very difficult. Also, we would like to estimate how overall urban and rural poverty rates have changed between 2018 and 2020. And creating AMAG level models would not allow us to do that. So the approach we took instead was to combine urban areas of AMAGs with other similar urban areas of AMAGs and correspondingly rural areas of AMAGs with other similar rural areas of AMAGs to create 14 different AMAG groups. And this approach allows us to estimate not only AMAG level poverty rates, but also urban and rural and national poverty rates. One thing to note is that using AMAG group models does not allow us to estimate poverty rates for at the location level. So for AMAG centers, Zoom centers, and the countryside. So the 14 groups were formed with the help of the NSO survey team based on similarity in livelihoods, geographic location, and some other household characteristics. We ultimately ended up with 8 urban AMAG groups, one of which was Ulaanbaatar, and 6 rural AMAG groups. As you can see here, the groups were for the most part geographically close together. And for each of these 14 groups, we created a separate model using the 2018 HSCS. So here I've included one example of a model. This is for urban group 8, which includes urban areas of Umnugovi, Orkhan, and Dornogovi. The outcome variable is log per capita consumption. And on the left, we can see the variables that were selected by the stepwise regression to create the optimal model based on the 2018 data. There are a number of time invariant variables that were included in this particular model, including the dependency ratio, household size, education of the household head, and dummies for which AMAG the household lived in. And we also have some time variant variables, including whether or not the household consumed items such as footwear, bed coverings, etc., and also whether the household head was working at the time of the survey. So the pool of time variant variables for rural AMAG groups also included indicators for whether or not the household consumed certain food items, but these were not included for the urban AMAG groups because the urban food diary had changed, the questionnaire had changed, as I mentioned earlier. The column highlighted in blue shows the coefficient for each variable, which we checked with the NSO to make sure that they all made sense. So this is an example of one model, and we did this for each of the 14 groups. Okay. So once the 14 models were all estimated, we were able to check how well they performed by comparing the predicted poverty rate to the actual one in 2018. And we can see for the 14 AMAG groups, the predicted poverty rate, which is denoted by the red dot, is very close to the actual poverty rate, which is the blue dot. There's some pretty minor differences, but all the imputed poverty rates lie within the 95% confidence interval of the actual ones. So this means that all the models were performing very well in predicting group level poverty rates. However, a more important question is how well the 14 models predict national, urban, rural, and AMAG level poverty rates, since the groups are just something that we put together for the purposes of this exercise. And here we can see that the models also do a very good job of predicting national urban and rural poverty rates in 2018. Differences between the actual and imputed rates are very small and statistically insignificant. At the AMAG level, there are some bigger percentage point differences between the actual and predicted poverty rates, but none of these are statistically significant, which is indicating that the 14 models are performing very well. So finally, in the fifth step, we validate the models on the 2016 HSES to check how well they can predict poverty in other years. And you can see that the percentage point differences between the actual and predicted poverty rates at the national, urban, and rural levels are a bit larger than they were for 2018, but the predicted poverty rates all lie within the confidence interval of the actual. Also at the AMAG level, with the exception of 2 AMAGs, the differences between the actual and imputed poverty rates are not statistically significant at the 5% level. So in summary, these results suggest that the 14 models are actually doing a decent job of predicting poverty, not only in 2018, but also in 2016. And this means that the model is likely to also do a good job of predicting poverty in 2020. We should, however, be mindful that predictions are not going to be right on point. So we should also consider whether changes between 2018 and 2020 are statistically significant before saying that poverty increased or decreased between these 2 years. Okay, so to finish, I'll quickly go over the main results of the 2020 poverty estimation. The estimated poverty rate in 2020 is 27.8%, which is a slight decline from 28.4% in 2018, but the change is not statistically significant. And so this suggests that the poverty rate didn't change much between 2018 and 2020, but we also should consider that if the pandemic had not taken place in 2020, poverty would have likely been even lower than what we see here of 27.8%. And indeed, we use the SWIFT methodology to simulate what poverty in 2020 would have been in the absence of the pandemic. And we found that the poverty rate would have decreased to about 24.3%. So this indicates that poverty increased by about 3.5 percentage points in 2020 due to the pandemic. And we can see this result in both urban and rural areas as well. At the AMAG level, there were some changes in the poverty rate between 2018 and 2020, but most changes were not statistically significant, and many differences across AMAGs within a given year were also not statistically significant. So this makes it difficult to actually rank AMAGs by their poverty rate. Because many of the 95% confidence intervals are quite large, which is primarily due to sample sizes being small in the 2020 and 2018 HSES. But the good news is that the survey team has increased the sample size substantially for the 2022 HSES, which will definitely improve precision at the AMAG level. And finally, you may be wondering whether SWIFT Plus can accurately predict changes in inequality in addition to changes in poverty. And the answer is that it can. This table shows that the actual and imputed Gini coefficients are almost identical at the national, urban, and rural levels. And the results suggest that inequality has not changed between 2018 and 2020. Okay, so that's the end of my presentation. Thank you for listening. Once again, for those who are interested in reading more about the detailed process and the results, you can take a look at the technical note, which I believe will be made available through the NSO. Thanks.
Дэлхийн банкны зөвлөх ЛИДИА КИМд баярлалаа. Маш наривчлсан тодорхой энэ 20 оны ядуурлыг хэрхэн тооцсон бэ? Үр дүнгийн талаараас танилцуулсанд баярлалаа.